Hello, honorable judges. This is Adam from Tsinghua University. Here, I would like to present our design for the competition to you. But wait a moment, I have to ask you a question first. Have you been to Latin American countries such as Brazil, Mexico, Colombia, and African countries recently? If your answer is yes, you probably should go to the hospital first to check out whether you have been infected by the Zika virus.
And more than 1 million people have been infected since then.
Just to put that, pregnant women contract Zika, they can pass it on to their fetuses, and this in turn can cause terrible birth defects.
The type of mosquitoes that spread Zika live in warm areas all over the world, including the US.
There are about 7 billion people on the planet and 3.2 billion people at risk of contracting malaria. 198 million people were infected with malaria in 2012 alone, and an estimated 584,000 people died from it. That's almost the total population of Las Vegas. And it's not just malaria. Mosquitoes also spread West Nile virus. There have been an estimated 40,000 cases in the US alone. The insect also carries dengue fever, which kills about 22,000 people every year.
Mosquitoes have always been an annoying or even dangerous animal in the world. In summer, they are extremely disturbing, and what's important, they are the vectors of many deadly diseases, as said in the video before. Our design is an Epidermal nanosensor for sensing mosquito and mosquito-carried virus specific detection. Our design has 3 functions. The first one is to sense the mosquito's approach. The second one is sensing the mosquito's bite after it lands on your skin. The third one is detecting whether the mosquito who has bitten you carries deadly virus. Our design can sense the mosquito's approach by 2 levels, far-field sensing and near-field sensing. In far-field sensing, the sensor applies to the situation that the mosquito is in a distance to the human. The sensor responds to the sound wave of the mosquito's wings, which has the frequency of about 300 to 500 Hz. The sensing part is a PZT electrode placed on cylinder resonator. The resonance frequency of the cylinder is equal to the frequency of the mosquito wings, so the sound wave caused by the mosquito's wings can make the cylinder to vibrate. Then the vibration caused the PZT electrode to deform, yielding electrical signals. When the mosquito is very near to the sensor, the near-field sensing works. The sensor owns a forest of zinc oxide nanowires on the surface. When the mosquito flies over the nanowire forest, the wind caused by the mosquito wings will make the nanowire to bend and shake, just like the grass in the grassland with a helicopter taking off. According to the research of Professor Zhonglin Wang from Georgia Tech, the bending of the zinc oxide nanowires will generate electricity. Look at the process of mosquito bite. We can find that they insert their mouthpart into the skin and suck blood from the vessel. Inspired by that, we use conductive self-healing polymer to detect mosquito's bite. When the mosquito inserts their mouthpart into the conductive polymer, its resistance will change because of inner crack. By measuring the resistance change, we can notice mosquito bite. After the mosquito finishing biting and draw back its mouthpart, the self-healing property can repair the crack and return to initial resistance for repeatable use. If unfortunately, all the above methods fail to stop the mosquito from biting you, the last thing you want is being infected by mosquito-carried virus. By specifically detecting and alerting whether the mosquito carried the virus and what type it is, the victim can immediately know whether they are infected or not. They can turn to medical treatments much earlier before symptoms such as fever and skin rash occur. The first way is by detecting the biting time and motion in the conductive self-healing polymer. For example, mosquitoes with malaria virus take longer time in biting than non-virus mosquitoes. By distinguishing the biting time and mode, some kind of virus can be confirmed. The second way is by specifically detecting the virus in mosquito saliva using antibody-modified gold nanoparticles. After the mosquito splits saliva into the middle layer of the sensor, the gold nanoparticle modified with relating virus antibody will react specifically with the virus. That will lead to particular resistance change of the gold nanoparticle. By measuring the resistance change, the type of the virus can be solely determined.
Our sensor solves the problem of being bitten by the mosquito and getting infected by the mosquito-carried virus. Our sensor can sense the mosquito's approach and then alert people to move their body in order to avoid being bitten by the mosquito. Then the sensor can also tell the user whether they have been infected by the virus carried by the mosquitoes after they are bitten for immediate medical treatment. Our customer segments are people who live in hot places such as Latin America, Africa, and Southeast of Asia, where mosquitoes, especially virus-carried mosquitoes, are a major threat to their daily life. Others include outdoor adventures, tourists, and volunteers and staffs who will visit those places for working and traveling. Having such a mosquito sensor, those people, our customers, can get rid of the risk of being bitten and getting infected by deadly diseases in those places where the medical treatment and healthcare conditions are really poor. Our key partners are outdoor equipment companies, medical equipment companies, and hospitals. And outdoor equipment companies can sell our sensor together with their outdoor clothes and other stuffs. And the hospital can offer our sensor to the people who are susceptible to diseases carried by mosquitoes as a medical equipment. Our sensor is the first one in the world as a mosquito sensor. No similar pattern has been found on the website of the World Intellectual Property Organization, and our revenue model is by licensing to our partner for production after applying for patents. That's all for our design. Thank you for watching.